Allow your shoulders to drop as you sink into the surface beneath you, feeling the steady support of the earth. Let your breath find a natural, effortless cadence, a soft rise and fall that signals to your mind that it is safe to rest. Even as you settle, your brain is performing its most cherished task, seeking out a rhythm. While we often think of the human brain as a seeker of novelty, it is, in its biological essence, an organ that craves the familiar. Consider the sheer energy required to sustain your consciousness. Although your brain accounts for only about 2% of your total body weight, it consumes a staggering 20% of your body's daily energy intake. Because of this high metabolic cost, the brain has evolved to be a master of efficiency, and the primary tool it uses to save energy is repetition. When we encounter something new, the brain must work at full capacity, firing neurons in complex, unmapped sequences. But when a pattern repeats, the brain can shift into a power-saving mode. Here's something most people don't know. By turning a sequence of actions into a repetitive habit, the brain can reduce its neural activity in certain regions by up to 80%. It is the biological equivalent of a river carving a smooth channel through stone. The first time the water flows, it must fight the resistance of the earth. But over time, the repetition creates a path of least resistance. As you lie here, imagine the physical structure of these neural pathways. Within your cranium, there is a dense, intricate forest of nearly 86 billion neurons. When you experience something repeatedly, a process known as long-term potentiation, or LTP, begins to take place. This is a persistent strengthening of synapses based on recent patterns of activity. It is the literal, physical manifestation of the phrase, "practice makes perfect." What's fascinating is that this isn't just a metaphorical strengthening. The connection between neurons actually becomes physically more robust. Think of a single axon, the long, slender projection of a nerve cell. When a thought or action is repeated, specialized glial cells called oligodendrocytes begin to wrap that axon in a fatty, insulating substance known as myelin. Myelin is a pearly white glistening material composed of roughly 80% lipids and 20% proteins. It acts exactly like the insulation on an electrical wire. In an unmyelinated sheath, an electrical impulse might crawl along at a speed of only 0.5 meters per second. However, as repetition triggers the thickening of this white matter, the speed of that signal can accelerate to a breathtaking 120 meters per second. This is why a familiar song or a repetitive bedtime story feels so effortless to process. The information is quite literally flying through your mind on high speed, well-insulated tracks, requiring almost no effort from you at all. This biological preference for the known is what psychologists call the mere exposure effect. First identified by Robert Zajonc in 1968, this phenomenon demonstrates that people tend to develop a preference for things merely because they are familiar with them. From an evolutionary perspective, this served as a vital survival mechanism. If a prehistoric ancestor saw the same type of berry or the same clearing in the woods every day and did not die, the brain tagged that object or place as safe. Novelty, while interesting, represents the unknown, and the unknown represents potential danger. Repetition is the brain's way of whispering, "You are safe. We have been here before." As you listen to the rhythmic cadence of my voice, you might notice a sense of deepening calm. This is partly due to the way your brain processes sensory input through the prediction engine of the prefrontal cortex. Your brain is not a passive observer of the world. It is a proactive prediction machine. It uses past repetitions to build internal models of what should happen next. When those predictions are met, when the next word follows the expected rhythm, or the next breath matches the one before it, the brain releases a gentle pulse of dopamine. We often think of dopamine as the chemical of excitement, but in the context of repetition, it provides a sense of predictive reward. It is the quiet satisfaction of the brain saying, "I knew that was coming." Deep within the center of your brain, beneath the folded layers of the cerebral cortex, lies a cluster of nuclei called the basal ganglia. These structures are the silent architects of your routines. While your thinking brain, the prefrontal cortex, is busy with complex decisions, the basal ganglia are observing. Once a behavior or a sensory pattern has been repeated enough times, the basal ganglia take over the script. This allows the rest of your brain to relax. It's why you can drive a familiar route home and realize you don't remember the last 5 miles, or why the repetitive sound of rain on a tin roof can lull you into a trance. The basal ganglia have recognized the pattern, and they have given the rest of your mind permission to go offline. Even the architecture of the natural world seems designed to soothe our brains through repetition. Consider the concept of fractals, complex patterns that repeat at every scale. You see them in the branching of a fern, the veins of a leaf, or the jagged edge of a coastline. Research has shown that looking at these natural repetitive fractals can reduce a person's physiological stress levels by as much as 60%. This is because our visual system has evolved to process the repetitive geometry of nature with extreme efficiency. When we see a fractal, our brains don't have to work hard to understand the whole, because the part already told us the story. This is fluent processing, a state where the brain feels a sense of ease and aesthetic pleasure, because the information is so easy to digest. The very rhythm of your life is governed by the most fundamental repetition of all, the circadian rhythm. This 24-hour cycle is managed by a tiny region in the hypothalamus called the suprachiasmatic nucleus, or SCN. The SCN is a master clock containing about 20,000 neurons that keep time with the repetition of light and dark. It regulates your body temperature, which dips to its lowest point in the early hours of the morning, usually around 4 a.m., and it controls the rhythmic release of melatonin from the pineal gland. Your body does not just happen to fall asleep. It follows a highly choreographed, repetitive chemical symphony that has played every night of your life. As you feel the weight of your limbs, consider the sensation of the air against your skin. Perhaps it is cool, a gentle contrast to the warmth of your blankets. This tactile feedback is processed by the somatosensory cortex, which, like the rest of the brain, loves a steady state. When a sensation is constant, like the feel of your pajamas or the weight of a quilt, your brain undergoes sensory adaptation. The receptors in your skin stop sending signals about the constant pressure to the brain. This is another form of repetition-based efficiency. By ignoring the repeated sensation of the bed beneath you, your brain clears the way for you to drift deeper into the internal world of sleep. Interestingly, about 40% of our daily behaviors are not the result of conscious decisions, but are habits, repetitive loops triggered by environmental cues. This chunking of behavior allows us to navigate a complex world without constant mental exhaustion. In the realm of memory, we rely on the hippocampus to consolidate these repetitions. While the hippocampus is the initial stage for learning, it is during sleep, during the repetitive oscillations of slow-wave brain activity, that memories are moved to the long-term storage of the neocortex. During sleep, your brain replays the day's repetitions at high speed, firing the same neural sequences over and over to ensure the pathways are permanently etched. Even the way we perceive time is influenced by repetition. Have you ever noticed how the first day of a vacation feels incredibly long, but the final days seem to fly by? This is because the first day is full of new, non-repetitive stimuli that the brain must process intensely. By the end of the week, the environment is familiar. The brain processes it faster, and time seems to contract. In the context of falling asleep, we want time to lose its edges. We want the repetition of the breath and the familiar texture of the evening routine to signal to the brain that no new information is coming. There is a specific type of brainwave associated with these repetitive low-effort states, the theta wave. Typically oscillating at 4 to 8 Hz, theta waves are the dominant frequency during deep meditation, light sleep, or the flow state one enters during repetitive tasks like knitting or long-distance walking. In this state, the filter between the conscious and the subconscious mind becomes porous. The brain is no longer looking for problems to solve. It is simply existing within the flow of the pattern. As we continue this journey, we will look closer at the microscopic world of these neural pathways, the way the chemicals dance across the synapses in a rhythmic, predictable ballet. We will explore the way trees in a forest use the repetition of the seasons to build their strength, and how the tides follow the moon in a loop that has remained unbroken for billions of years. For now, simply allow the facts of your own biology to comfort you. You are a creature of habit, a masterpiece of biological repetition, designed to find peace in the familiar. And the brain is not just an organ, it is a historian of your repetitions. Every time you take a deep, slow breath, you are reinforcing a neural pathway that says, all is well. Each repetition of the breath is a stitch in a vast, soft blanket of calm that you are weaving around yourself. The cool air enters, the warm air leaves, the lungs expand, the lungs contract. It is the most basic, beautiful repetition in the world, and your brain loves it. As the basal ganglia manage the scripts of your evening, quietly dimming the lights of your conscious focus, we can look back at how humans first began to decode this rhythmic internal language. Imagine a laboratory in the year 1949, where a psychologist named Donald Hebb is observing the minute interactions of nerve cells, and he proposed a concept that would change our understanding of the mind forever, now famously known as Hebbian theory. He posited that cells that fire together wire together. This wasn't just a catchy phrase. It was a description of a physical, structural change. When one neuron repeatedly assists in firing another, the chemical connection between them, the synapse, physically strengthens. It is as if the brain is a loom, and every repeated thought is a pass of the shuttle, reinforcing the fabric of your reality until it becomes a sturdy, dependable weight that provides comfort. Consider the history of how we measure the power of this repetition. In 1885, a German psychologist named Hermann Ebbinghaus conducted a series of rigorous experiments on himself to understand how we retain information. He discovered what is now known as the forgetting curve. He found that without repetition, the human brain loses approximately 50% of new information within just 20 minutes, and up to 90% within a few days. However, Ebbinghaus noted a curious phenomenon. Each time he reviewed the information, the rate of forgetting slowed down significantly. This spaced repetition effect suggests that our brains are not designed to hold on to the one-off events, but are biologically tuned to prioritize the signals that recur. In the stillness of your room, you are benefiting from this ancient filter. The brain is discarding the chaotic, singular noises of the day and holding on to the steady, repeated rhythm of your breath. Picture the way a tree records the passage of time through the repetition of the seasons. This field of study, known as dendrochronology, was pioneered by A.E. Douglas in the early 1900s. A single cross-section of a bristlecone pine, some of which live for over 4,800 years, reveals a series of concentric rings. Each ring is a testimony to a repeated annual cycle, the rapid growth of the light-colored early wood in the spring and the dense, dark late wood of the autumn. These rings are not just marks, they are a biological diary. Within your own brain, repetition leaves similar rings of density. Scientists have used MRI technology to observe that expert musicians, who spend thousands of hours in repetitive practice, actually have a significantly larger volume of gray matter in their motor cortex and auditory regions compared to non-musicians. The repetition physically expands the architecture of the mind, much like the steady layering of cellulose expands the girth of an oak. What's happening now, as your heart rate slows, is a transition into a state of neural oscillation. In 1924, Hans Berger, a German psychiatrist, recorded the first human electroencephalogram, or EEG. He was the first to witness the brain's electrical rhythms, specifically the alpha waves. These waves, which oscillate between 8 and 12 cycles per second, appear the moment you close your eyes and settle into a relaxed, repetitive state. They are the brain's idle rhythm, a signal that the heavy processing of the day is concluding. At this very moment, your brain is shifting from the jagged, fast beta waves of active problem solving into the smooth, rolling sea of alpha and eventually theta waves. And this transition is paved by the repetition of the environment, the same bed, the same pillow, the same temperature, all signaling that the cognitive work is done. Deep within the microscopic landscape of your sleeping brain, a remarkable process of synaptic pruning begins. During the day, your brain creates millions of new connections as you experience new things. However, if the brain kept every single one, it would become cluttered and inefficient. To solve this, the brain uses a process called long-term depression, or LTD. This is the functional opposite of the strengthening process we discussed earlier. While repeated signals are fortified, those signals that were only experienced once, the face of a stranger in a crowd, the color of a passing car, are weakened and eventually dismantled. This ensures that only the most vital, repeated patterns remain. It is a nightly curation, a quiet sweeping of the mind's galleries to ensure that tomorrow you wake with a clear, efficient space. Notice how the natural world utilizes mathematical repetition to optimize life. In the 13th century, the mathematician Fibonacci described a sequence of numbers where each is the sum of the two preceding ones. This sequence creates a golden spiral, a pattern that repeats throughout nature because it is the most efficient way for an organism to grow without crowding itself. You can see this in the seeds of a sunflower, which are arranged in two sets of spirals, usually 34 in one direction and 55 in the other. In larger sunflowers, these numbers jump to 89 and 144. This repetitive geometry allows the plant to pack the maximum number of seeds into the smallest space, ensuring the next generation's survival. Your brain, too, uses repetitive geometries in its firing patterns to pack the maximum amount of experience into its neural networks. At this stage of your relaxation, you might experience sleep spindles. These are sudden bursts of oscillatory brain activity, usually occurring at a frequency of 11 to 16 Hz, lasting for about half a second. First identified in the 1930s, These spindles are a hallmark of stage 2 NREM sleep. They are incredibly important for sensory detachment. The more sleep spindles your brain produces, the more likely you are to stay asleep, even if there is a noise in the room. What's fascinating is that these spindles are involved in memory consolidation, specifically for repetitive motor tasks. If you learned a new physical skill today, your brain is currently replaying that skill in those half-second bursts, repeating the neural sequence up to 20 times faster than it happened in real life. It is as if your brain is practicing for you while you rest. Consider the sensation of your breath again. As you inhale, notice the slight coolness at the tip of your nose, and as you exhale, the warmth of the air as it leaves. This is a form of sensory repetition that humans have used for millennia to induce calm. In many historical traditions, practitioners used mala beads or rosaries, strings of beads used to count repetitive prayers or mantras. Modern neuroscience has found that this tactile repetition combined with a repetitive phrase can actually lower cortisol levels, the body's primary stress hormone, by up to 20%. The physical act of moving a bead between the fingers creates a rhythmic anchor for the mind, preventing it from drifting into the turbulent waters of future anxieties or past regrets. Even your smallest cells are governed by a repetitive genetic clock. In 1984, researchers discovered the period gene in fruit flies, a gene that actually builds up a specific protein during the night and degrades it during the day. This molecular repetition exists in almost every cell in your body. This is why you might feel a second wind or a sudden drop in energy at the same time every day. It is the physical manifestation of your cellular clock repeating its cycle. As you lie here, these proteins are reaching their nightly peak, signaling to your mitochondria, the powerhouses of your cells, that it is time to shift from energy production to cellular repair. Deep within the fluid-filled spaces of your brain, a specialized system is currently becoming active. Discovered as recently as 2012 by Maiken Nedergaard, the glymphatic system is the brain's unique waste clearance pathway. During the day, the space between your brain cells is quite small, making it difficult for fluid to flow. But as you enter a state of deep repetitive rest, your brain cells actually shrink by about 60%. This creates a much larger space for cerebrospinal fluid to rush in and sweep away metabolic byproducts, such as beta amyloid, which build up while you are awake. This process is most effective when your heart rate and breathing are slow and steady, the very state you are entering now. And the repetitive pulsing of your arteries helps to drive this fluid through the brain tissue, ensuring you wake up with a refreshed neural landscape. Think of the way an infant learns to speak. This is driven by what psychologists call statistical learning. In a famous 1996 study by Jenny Safran, it was discovered that 8-month-old babies can distinguish between words and non-words simply by the frequency and repetition of sounds. They aren't learning grammar yet. They are simply tracking which sounds are most likely to follow one another. Their brains are little supercomputers of repetition, building a map of language out of the sheer frequency of human speech. This ability to find patterns in repetition never leaves us. It is why the familiar structure of a story or the steady cadence of a voice is so inherently soothing. It speaks to the oldest, most fundamental way we learned to understand the world. As you continue to settle, imagine the myelin sheathing we spoke of earlier. Repetition doesn't just speed up signals, it makes them more accurate. When a nerve impulse is repeated, the thickness of the myelin can increase, and the distance between the nodes of Ranvier, the gaps in the sheath, can be optimized. This reduces the leakage of the electrical signal, ensuring that the message reaches its destination with 100% fidelity. In the quiet of the night, your brain is tuning these connections, ensuring that the pathways you used most today are ready and resilient for tomorrow. Grant your body permission to fully lean into the mattress, acknowledging that every repetitive cycle of your heart and lungs is a heartbeat of safety. You are part of a world that repeats its successes. The moon will continue its 27.3-day orbit. The tides will continue their 12.4-hour cycle, and your brain will continue its nightly ritual of reorganization and rest. There is no need for novelty now. The known is your sanctuary. The familiar rhythm is your guide. The story of your day is being edited, polished, and stored away, leaving you with nothing to do but exist within the gentle, repeating waves of your own peace. Picture this. Your mind is like a master potter's studio. The initial thoughts of your day were like raw, unformed lumps of wet clay, heavy with moisture and full of grit. But as the hours progressed and routines took over, those thoughts were placed upon a spinning wheel. Repetition is the hand of the potter, applying a steady, rhythmic pressure that smooths the rough edges and thins the walls into a delicate, functional vessel. What was once chaotic and heavy becomes light and structured. As you rest now, the kiln of sleep is beginning to fire, hardening those repetitive shapes into permanent structures of memory and habit. Consider the humble California sea slug, known scientifically as Aplysia californica. This creature, though it possesses only about 20,000 neurons, compared to your 86 billion, provided the foundational evidence for how your brain learns through repetition. In the late 20th century, Eric Kandel, who later won the Nobel Prize in 2000, observed that if he repeatedly touched a slug's siphon with a gentle jet of water, the creature eventually stopped retracting its gill. This is a process called habituation. At a microscopic level, the repetition caused the sensory neurons to release less of the neurotransmitter glutamate into the synaptic cleft. This decrease in chemical signaling is the brain's way of saying, this stimulus is not a threat, we can ignore it. Within your own mind, the repetitive sounds of your environment, the hum of a fan, or the distant rhythm of traffic, are being muted by this same biological habituation, allowing you to settle without distraction. Notice how the natural world relies on these long-term cycles to maintain equilibrium. Deep within the soil of the eastern United States, the Magicicada nymphs are currently waiting. These periodical cicadas follow a repetitive life cycle of exactly 13 or 17 years, depending on the species. For over a decade, they remain underground, sipping sap from tree roots in total darkness, accounting the repetitive cycles of the seasons through the chemical changes in the tree's fluid. When the 17th year finally arrives and the soil temperature reaches exactly 64 degrees Fahrenheit, they emerge in their millions. Their survival is entirely dependent on this precise, repetitive timing, a biological clock so accurate it rivals the most sophisticated human chronometers. At this very moment, your own internal clock, the suprachiasmatic nucleus, which is no larger than a grain of rice, is coordinating a similar synchronization. It is managing the production of melatonin, a hormone synthesized from the amino acid tryptophan. As light levels have faded, the repetition of this evening signal has prompted your pineal gland to steadily increase melatonin concentrations in your blood. This is not a sudden switch, but a rhythmic tide. Much like the Arctic tern, which travels a staggering 44,000 miles in a repetitive annual loop from the Arctic to the Antarctic and back, your biology is navigating a vast, predictable journey toward the restorative pole of deep sleep. Scientists discovered a fascinating phenomenon in 1994 called the Tetris effect. In a study conducted at Harvard, researchers found that people who played the tile-matching game for several hours a day began to see those geometric shapes in their dreams, and even when they looked at everyday objects in the real world. This occurs because the brain is so highly tuned to repetition that it continues to look for the known pattern even after the stimulus has stopped. It is a form of cognitive echo, similar to the way you might still feel the motion of waves after a day on a boat. This echoic memory is a sensory buffer that holds on to auditory information for about 4 seconds, giving your brain just enough time to link one sound to the next and create a coherent sense of language or music. What's happening now is a shift into what neuroscientists call oscillatory synchrony. When you are focused on a single repetitive object or thought, neurons in your visual and parietal cortex begin to fire in perfect unison, often at a frequency of 40 Hz, known as gamma oscillations. Think of this like a large crowd at a stadium performing The Wave. When everyone is doing something different, it is just noise. But when the repetition of the wave begins, the collective movement creates a powerful, visible rhythm. In your brain, this synchrony helps to bind different sensations together into a single, peaceful experience of the present moment. Deep within the brain's structure, the posterior hippocampus is a region dedicated to spatial navigation. In a famous study of London taxi drivers, researchers found that as these drivers repeatedly navigated the complex winding knowledge of London's 25,000 streets, the gray matter in their posterior hippocampus physically grew. The repetition of the routes acted like a workout for the brain, increasing the density of the neural tissue. You can compare this to the way a gardener might constantly turn the soil in a specific bed to keep it aerated and fertile. By returning to the same mental paths every night, the same relaxation techniques, the same breathing patterns, you are physically strengthening the parts of your brain that govern calm and recovery. Consider the rhythmic precision of a bird learning its song. A young zebra finch will listen to its father's song and then repeat a single motif up to 1,000 times a day. During this plastic song phase, the bird's brain is constantly comparing its own repetitive chirps to the stored memory of the original song, making minute adjustments to the tension of its syrinx, the avian vocal organ. This power law of practice applies to you as well. The time it takes for your brain to execute a command, like relax the jaw or soften the gaze, decreases every single time you repeat the action. Eventually, the action requires zero conscious effort. It becomes an automated program, like the software updates that run in the background of your phone while you are asleep. At this very moment, your heart is performing its own magnificent repetition. In an average day, your heart beats approximately 100,000 times, pumping between 2,000 and 3,000 gallons of blood through 60,000 miles of vessels. This rhythm is not perfectly steady, and that is actually a sign of health. Heart rate variability, or HRV, is the minute variation in the time interval between heartbeats. A high HRV indicates that your autonomic nervous system is flexible and can easily shift between the fight or flight sympathetic mode and the rest and digest parasympathetic mode. As you listen to this, your HRV is likely increasing, a repetitive signal to every organ in your body that the environment is safe and the time for repair has arrived. Think about the illusory truth effect, a cognitive bias first identified in 1977 Researchers found that if a person hears a statement repeated several times, they are significantly more likely to believe it is true, regardless of its actual validity. This is because repetition creates processing fluency, the ease with which information moves through the brain. When something is easy to process, the brain mistakes that ease for truth and safety. You can use this to your advantage tonight. By repeating a simple silent phrase, such as, "I am at rest," you are creating a sense of internal truth that your nervous system accepts as reality, bypassing the skepticism of the logical mind. Notice how the Earth itself is governed by a repetitive sidereal day, the time it takes for the planet to rotate once relative to the stars, which is exactly 23 hours, 56 minutes, and 4 seconds. This constant, the unyielding spin, provides the ultimate repetitive stimulus for all life. It is the reason why your cells undergo synaptic pruning. In the first few years of a human's life, the brain produces an excess of connections. A toddler actually has twice as many synapses as an adult. But through the repetition of daily life, the brain prunes away the ones that aren't used, much like a gardener clips back the overgrown branches of a hedge to maintain its shape and health. This nightly pruning is what makes your mind efficient, streamlined, and ready for the next day's rotation. Every 90 minutes or so, you will cycle through the different stages of sleep, from the light drift of stage 1 through the spindle-heavy stage 2, into the deep, restorative delta waves of stage 3, and finally, into the vivid repetition of REM sleep. This 90-minute ultradian rhythm is a fundamental heartbeat of the human experience. It is as predictable as the tides, which are pulled by the moon in a 12.4-hour cycle. Just as the tide leaves behind a clean, smooth beach, each 90-minute sleep cycle washes through your consciousness, smoothing out the footprints of the day's stresses and leaving a fresh, undisturbed surface. As you continue to breathe, imagine the very atoms that make up your body. Even they are in a state of constant repetitive vibration. Your breathing is the macro-scale version of this atomic dance. Every inhale is a gathering of energy, and every exhale is a release of tension. There is no need to seek out anything new. The magic is in the encore. The beauty is in the refrain. Your brain is a theater, and it is currently enjoying the most peaceful play it has ever known. A story where the ending is always the same, and the ending is always rest. Feel the white matter of your mind humming with the quiet efficiency of a well-paved road, leading you further away from the noise of the day and into the silent, repetitive beauty of the night. Within the silent theater of your mind, a profound transformation is taking place, one that echoes the grandest timescales of the natural world. Imagine the slow, relentless movement of a glacier. As a massive ice sheet, such as the Lambert Glacier in Antarctica, the largest in the world at over 250 miles long, moves across the bedrock, it does so with a repetitive, grinding weight. It doesn't reshape the landscape in a day, but through the consistent repetition of its passage over thousands of years, it carves deep U-shaped valleys and smooths the hardest granite. Your brain is currently undergoing a similar geological smoothing. The repetitive signals of your evening routine act as the weight of the ice, gently pressing down on the jagged edges of the day's worries, leveling them until only a vast, serene interior landscape remains. At this very moment, your brain is engaging its default mode network, or DMN. First identified by Marcus Rachel at Washington University in 2001, the DMN is a specific set of brain regions including the medial prefrontal cortex and the posterior cingulate cortex, that become highly active exactly when you stop performing tasks and settle into a state of repetitive rest. While your conscious mind drifts, this network is busy weaving the threads of your identity. It is the librarian of your soul, in taking the scattered pages of your recent experiences and binding them into the existing volumes of your life story. What's striking is that this network consumes nearly as much energy as your active task brain. Even in quietude, your mind is working with a steady, repetitive pulse to ensure that the you who wakes up tomorrow is a coherent continuation of the you who fell asleep. Deep within your cells, a microscopic form of repetition is influencing your very genetic code. This is the field of epigenetics, specifically a process called DNA methylation. Scientists have observed that repetitive behaviors, such as consistent exercise or even a long-term meditation practice, can cause methyl groups to attach to specific parts of your DNA. These acts of repetition don't change the genes themselves, but they act like a dimmer switch, in turning down the expression of genes related to inflammation and stress, and turning up the genes associated with cellular repair and immune function. In a study published in the journal Psychoneuroendocrinology, researchers found that just 8 hours of repetitive mindfulness practice could measurably downregulate pro-inflammatory genes. As you lie here, the simple repetitive act of resting is physically instructing your cells to enter a state of healing. Consider the timescale of your own body's renewal. It is a quiet wonder that you are never the same person for very long. Your skeleton, for instance, is not a static frame of bone. It is a dynamic living tissue that is constantly being broken down and rebuilt. Through a repetitive process called remodeling, specialized cells called osteoclasts remove old bone, while osteoblasts lay down new mineralized tissue. It takes approximately 10 years for this repetitive cycle to completely replace your entire skeleton. At this very moment, your body is performing this invisible maintenance, a silent, rhythmic turnover that ensures your physical foundation remains resilient. You are a masterpiece in a state of perpetual, repetitive revision. Look toward the stars, and you will find the same logic of repetition governing the climate of our planet over eons. These are the Milankovitch cycles, named after the Serbian geophysicist Milutin Milankovic. He calculated that the Earth's orbit changes its shape from a circle to an oval every 100,000 years, and its tilt oscillates every 41,000 years. These massive, repetitive celestial loops are responsible for the coming and going of ice ages. They are the heartbeat of the Earth's climate, a cycle that has repeated for millions of years. In the same way, your brain's preference for the familiar is a small-scale reflection of this universal law. Stability is born from the repetition of the grandest cycles. Notice the texture of your rest. Perhaps you feel a sensation akin to the smoothness of a river stone. In the depths of a cave, like the Mammoth Cave system in Kentucky, water drips from the ceiling in a rhythm that has not changed for millennia. Each drop carries a tiny amount of calcium carbonate. As the water evaporates, it leaves behind a microscopic layer of calcite. It takes roughly 100 years for a stalactite to grow just 1 inch, and this is the ultimate expression of the power of repetition. The transformation of a liquid drop into a solid stone spire through nothing more than persistence and time. Your neural pathways are being mineralized in much the same way tonight. Each repetitive thought of safety is a single drop of calcite, slowly building a structure of inner strength that is solid, enduring, and beautiful. Deep within the cerebellum, which sits at the base of your brain and contains more than half of your total neurons, your procedural memories are being polished. This region is the master of repetitive motor skills. When you learn to ride a bicycle or tie a knot, the cerebellum stores the script. During sleep, the cerebellum works in concert with the motor cortex to refine these repetitive sequences. Scientists discovered that during NREM sleep, the brain reruns these motor patterns at high speed. It's as if your mind is a musician practicing a difficult passage over and over in the quiet of the night, so that by morning, the movement is effortless. This is why a task that felt clunky and difficult yesterday often feels natural and fluid after a good night's rest. The repetition happened while you were unaware. What is particularly striking is the way your brain handles unfinished business. You might be familiar with the Zeigarnik effect, a phenomenon discovered by psychologist Bluma Zeigarnik in the 1920s. She noticed that waiters could remember complex, unpaid orders perfectly, but as soon as the bill was settled, the memory vanished. The brain holds on to open loops with a high degree of tension. However, when we engage in repetitive rituals, like locking the door, brushing our teeth, or following a guided narrative, we are closing the loops. Repetition signals completion. It tells the brain that the order is settled, allowing the tension to dissipate and the mental workspace to be cleared for the night. Think about the sound of a steady stream or the rustle of leaves in a light breeze. These are examples of pink noise, or 1/f noise. Unlike white noise, which has equal power across all frequencies, pink noise has more power at lower frequencies, creating a sound that is deeper and more repetitive to the human ear. A study from Northwestern University found that playing gentle, repetitive pulses of pink noise during deep sleep can actually enhance the size of your slow-wave brain oscillations. This, in turn, improved the memory recall of the participants by nearly 25% the next morning. The repetitive rhythmic sound literally amplified the brain's ability to heal and store information. Even your sense of smell is part of this repetitive landscape. The olfactory bulb is the only part of the brain that is directly exposed to the environment, and it has a unique relationship with the hippocampus. If you use the same scent every night, perhaps the smell of lavender or clean cotton, that repeated chemical signal becomes a powerful anchor. In a process called context-dependent memory, the brain associates that specific repeated scent with the state of sleep. Eventually, the moment you smell that fragrance, your brain automatically begins to trigger the release of GABA, or gamma-aminobutyric acid, GABA. GABA is the brain's primary inhibitory neurotransmitter. Its job is to reduce the activity of the neurons it binds to, acting as a chemical mute button for the nervous system. At this very moment, your brain is also managing its synaptic scaling. During the day, as you learn and experience, your synapses grow stronger and larger. However, if they kept growing indefinitely, they would eventually hit a ceiling and be unable to learn anything new. During the repetitive cycles of sleep, the brain performs homeostatic downscaling. It systematically weakens all synapses by a small proportional amount. This preserves the relative strength of the most important, repeated connections, while lowering the overall background noise of the brain. It is like a gardener who trims the entire hedge to a lower height, ensuring that the strongest branches still stand out, but the whole plant remains manageable and healthy. Consider the peak end rule, a psychological heuristic discovered by Daniel Kahneman. he found that people tend to judge an experience based on how they felt at its peak and how it ended, rather than the total sum of the experience. By ending your day with this repetitive educational journey, you are hijacking this rule. You are ensuring that the end of your waking day is one of profound calm and structural stability. This final impression will color your entire night's rest, providing a peaceful summary that your brain will use to categorize the preceding 16 hours. As the temperature of your skin slightly rises and the temperature of your core drops, a repetitive thermoregulatory dance that occurs every night, allow yourself to feel the vastness of the system you belong to. You are not a solitary mind struggling to find peace. You are a biological entity responding to the same laws that govern the tides, the growth of stalactites, and the orbit of the planets. There is a deep structural comfort in knowing that your brain's love for repetition is not a flaw, but a finely tuned instrument of survival and efficiency. The grooves being worn into your mind tonight are paths of ease, leading you toward a sanctuary of deep, uninterrupted restoration. The weight of the day has been redistributed. The valleys have been smoothed. The loom is at rest. And the tapestry of your consciousness is complete for now. Deep within the brainstem, a collection of neurons known as the reticular activating system, or RAS, acts as your internal sentry. This dense network of cells is responsible for the orienting reflex, a concept first described by Ivan Pavlov. When you hear a sudden, novel sound, the RAS fires instantly, pulling your attention toward the change to assess if it represents a requirement for action. However, when a sound or sensation repeats without variation, like the steady, low-frequency hum of a distant motor or the rhythmic pulse of a clock, the RAS undergoes efferent inhibition. It essentially tells the rest of your brain that this specific signal is unimportant. At this very moment, your RAS is performing a quiet act of filtering, you categorizing the repetitive sounds of your room as background, which allows your cortical activity to subside. Consider the microscopic chemistry occurring at your synapses. For a neuron to fire, it must release neurotransmitters, which require calcium ions, to enter the nerve terminal. When a stimulus is repeated frequently, but carries no new information, the calcium channels in those neurons begin to close slightly. This phenomenon, known as synaptic depression, is the reason why a repetitive sensation becomes less loud over time. Scientists discovered this by studying the Mimosa pudica, a sensitive plant that folds its leaves when touched. In experiments conducted by Monica Galliano in 2014, she found that if the plant was repeatedly dropped a short distance without being harmed, it eventually stopped folding its leaves. The plant learned, through repetition, that the stimulus was irrelevant, and remarkably, it remembered this for over 4 weeks. Your own nervous system is currently utilizing this ancient biological logic to ignore the pressure of your clothes and the weight of your limbs, clearing the mental stage for rest. Picture the brain as a biological pendulum, seeking its own center through the law of entrainment. This physical principle was first observed by Christian Huygens in 1665, when he noticed that 2 pendulum clocks hanging on the same wall would eventually synchronize their swing. Your brainwaves do the same. When you are exposed to a repetitive, rhythmic sound, your neural oscillations begin to match the frequency of that external pulse. This is why a resting heart rate of about 60 beats per minute is so calming. It mirrors the 1.0 Hertz frequency that characterizes the deep delta waves of stage 3 sleep. By synchronizing to a slow, repetitive rhythm, You are physically pulling your brain away from the high-frequency jitter of 30 Hz gamma waves and into the long, slow 1 to 4 Hz swells of restorative slumber. What's happening now involves a chemical known as adenosine, a byproduct of the breakdown of adenosine triphosphate, or ATP, which is the primary energy currency of your cells. Throughout the day, as your neurons fire, adenosine levels steadily rise in the basal forebrain. This creates sleep pressure. Adenosine binds to A1 receptors, which directly inhibits the release of arousal-promoting neurotransmitters like acetylcholine and dopamine. Here's a detail many people miss. The brain loves the repetition of the sleep cycle because it is the only time the glymphatic system can effectively clear this adenosine buildup. As you settle into this repetitive narrative, the concentration of adenosine is reaching its peak, making the power-saving mode of sleep feel not just pleasant, but inevitable. At this very moment, your core body temperature is beginning its nightly descent, a process governed by the circadian nadir. For the human brain to enter deep sleep, the internal core temperature must drop by approximately 1 to 2 degrees Celsius, about 2 to 3 degrees Fahrenheit. To facilitate this, your body engages in vasodilation, widening the blood vessels in your hands and feet to radiate heat away from your core. When this is why you might find comfort in sticking a foot out from under the covers, you are aiding a repetitive thermal cycle that has occurred every evening of your life. Scientists have found that the optimal ambient temperature for this repetitive cooling is between 60 and 67 degrees Fahrenheit. As your core cools, your metabolic rate drops by about 15%, further reducing the energy demands on your brain. Notice how the natural world utilizes repetitive chemical signals to coordinate vast, invisible events. In the dark depths of the ocean, certain species of dinoflagellates, like Pyrocystis fusiformis, follow a strict circadian rhythm for bioluminescence. During the day, they remain dark to conserve energy, but as the sun sets, they move their luciferase enzymes to the periphery of their cells. If the water is agitated repetitively by the movement of waves or a passing fish, they emit a brilliant blue light. This repetitive light response is so finely tuned that it only occurs during the organism's subjective night, even if they are kept in a laboratory in total darkness. Your brain's release of melatonin follows a similar subjective schedule, a repetitive chemical tide that persists regardless of your environment. Deep within your auditory system, the Turnus effect demonstrates how your brain prefers to group repetitive motions together. If two dots are flashed repetitively in a specific sequence, the brain doesn't see two separate objects. It perceives a single object moving back and forth. This perceptual grouping is a shortcut the brain uses to make sense of the world with minimal effort. In the context of this story, your brain is grouping the repetitive cadences of my speech into a single cohesive stream of information. This reduces the switching cost, the energy required to move attention from one discrete piece of data to another, allowing your prefrontal cortex to finally disengage. Scientists discovered that even the cells in your skin have their own repetitive clocks. Research from the University of California, Irvine, showed that skin cells use their internal circadian rhythms to time their most critical functions. During the day, they focus on protection from ultraviolet radiation, but at night, they shift toward DNA repair and the production of new cells. This is because the metabolic noise of the day is too high for delicate repairs. Repetition allows these cells to predict when it will be safe to begin their work. As you lie still, your skin is literally rebuilding itself, a repetitive act of maintenance that requires your total lack of movement. Consider the metaphor of a biological tide pool. When the tide is high and the waves are crashing, much like your brain during a busy afternoon, the water is turbulent, and it's impossible to see the bottom. But as the tide pulls back in a repetitive, predictable retreat, the water becomes still. The sediment settles. You can see the intricate, repetitive patterns of the anemones and the rhythmic siphoning of the barnacles. Sleep is the low tide of your consciousness. The repetition of your breath is the water gently receding, while leaving behind a state of clarity and stillness, where the sediment of your daily thoughts can finally sink to the bottom. In the tropical forests of Southeast Asia, certain species of fireflies, such as Pteroptyx tenaire, gather in mangrove trees by the thousands. What's fascinating is that they don't flash at random. Through a process of repetitive synchronization, the entire tree begins to flash in perfect unison, once every second. This collective repetition makes the signal visible from miles away, far more effective than any single insect could be alone. Your brain's slow wave activity during deep sleep is the neural equivalent of those fireflies. Millions of neurons in your cortex, which were firing independently all day, begin to pulse together in a slow, rhythmic up state of high activity, followed by a down state of total silence. This one, Hertz rhythm, is the most restorative state the human brain can achieve, and it is built entirely on the power of synchronization and repetition. At this very moment, your thalamus, the grand central station of your brain, is beginning to close its gates. This walnut-sized structure relays almost all sensory information to the cortex. But during repetitive low-stimulation environments, the thalamus begins to generate its own internal rhythms, known as thalamocortical oscillations. These rhythms act as a barrier, preventing external sounds or sensations from reaching your conscious mind. This is the biological reason why you tune out the world as you fall asleep. The thalamus has shifted from being a gateway to being a rhythmic shield, repeating its own internal signal to keep the rest of your brain in a state of protected isolation. Notice the sensation of your heart again. It is currently being influenced by the vagus nerve, the longest nerve of the autonomic nervous system. The vagus nerve releases a neurotransmitter called acetylcholine, which acts as a braking system for your heart rate. Each time you exhale, the vagus nerve sends a repetitive pulse of acetylcholine to the heart's sinoatrial node, slowing it down. This is why long, repetitive exhales are so effective at inducing sleep. You are manually engaging your parasympathetic nervous system, sending a chemical message of slow down through your entire body. As we move toward the final chapter of this journey, acknowledge that your brain's preference for repetition is its most sophisticated survival tool. It is not a sign of boredom, but a hallmark of mastery. Your mind has mastered the art of being here, in this room, in this bed, at this time. The predictive reward of the familiar is now a steady warmth within you. Every cell in your body is following a cycle that began billions of years ago, a loop of activity and rest, of light and dark, of noise and silence. You are a part of that grand, repetitive harmony. The paths have been cleared. The gates are closing. The rhythm is your only master now, and it is leading you toward the most profound repetition of all, the daily return to the silence of the self. As the sun begins its final, repetitive descent below the horizon, the natural world initiates a choreographed sequence of closure. This process is known as nyctinasty, a phenomenon first described by Charles Darwin in his 1880 book, The Power of Movement in Plants. Consider the silk tree, or Albizia julibrissin. As the light levels drop below a specific threshold, the tree's leaflets begin to fold together in pairs. This movement is not caused by gravity, but by a precise change in turgor pressure within the pulvinus, a specialized joint-like organ at the base of each leaf. Potassium ions are pumped out of the extensor cells, causing the leaves to lose their internal water pressure and wilt into a protective, repetitive embrace. This nightly ritual reduces the plant's surface area, conserving heat and moisture. Your own body is currently following a similar chemical protocol, a step-by-step reduction of external interaction that has been perfected over eons. And notice how the atmosphere itself participates in this transition. As the Earth rotates at approximately 1,000 miles per hour at the equator, the side facing away from the sun begins to radiate heat back into the cold sink of space. This is the Stefan Boltzmann law in action, where the rate of heat loss is proportional to the fourth power of the absolute temperature. Scientists have observed that the air temperature typically drops by 0.5 to 1 degree Celsius every hour after sunset in calm conditions. This repetitive cooling is the primary environmental cue for your hypothalamus. In response, the body begins a process called distal vasodilation, where blood is shunted toward the skin of your hands and feet to release internal heat. By the time you reach deep sleep, your core temperature will have fallen by about 1 degree Celsius, a necessary requirement for the brain to enter its most restorative state. What's happening now within your neural architecture is the final transition into the slow-wave sleep phase, or Stage 3, NREM. This stage is defined by the appearance of delta waves, the slowest, highest amplitude brain waves, oscillating at a frequency between 0.5 and 4 Hertz. Scientists discovered that these waves are not just random noise. They are highly coordinated global oscillations. They originate in the prefrontal cortex and travel across the brain like a slow, repetitive tide at a velocity of about 2 to 3 meters per second. This rhythmic pulsing is the cleaner's bell for the brain. It is during these specific repetitive delta swells that the space between your neurons increases by up to 60%, allowing the glymphatic system to achieve its peak flow. At approximately 2 a.m., the concentration of metabolic byproducts, such as the protein fragment beta amyloid, is at its lowest as it is cleared through your cerebral veins. Deep within the peat bogs of the northern hemisphere, a different kind of repetitive process is occurring. These bogs are primarily composed of sphagnum moss, a genus containing over 380 species. Sphagnum moss is a master of repetition. It grows upward from the top, while the bottom parts slowly die and compress into peat. A single acre of peatland can store more than 1,400 tons of carbon, which is more than double the amount stored in an equivalent area of tropical rainforest. This occurs because the moss creates an acidic, anaerobic environment that repeats the same conditions for thousands of years, is slowing decay to a near halt. In a similar way, the stillness of your sleep creates a metabolic environment that slows the decay of your cognitive systems, allowing for the slow, steady accumulation of mental resilience. Consider the time scale of the bristlecone pine, Pinus longiva, found in the White Mountains of California. Some of these trees have been repeating the cycle of growth for over 5,000 years. Their growth is incredibly slow, sometimes adding only 1/100th of an inch of girth in a single year. This glacial pace is their strength. It produces a wood so dense and resinous that it is nearly impervious to insects and fungi. Your brain's preference for repetition works on a similar principle. By repeating the same sleep rituals, and the same calming thoughts, is you are building dense neural structures that are impervious to the weathering effects of daily stress. The repetition is not stagnant. It is the most durable form of growth. Scientists discovered that during this deep descent, the heart rate enters a state of bradycardia, typically dropping to between 40 and 60 beats per minute. Each beat is a repetitive signal that moves 70 milliliters of oxygen-rich blood through your aorta. As your heart slows, the intervals between beats become more regular, a sign that the parasympathetic nervous system has gained total control. This is the biological rest and digest state. At the same time, your respiratory rate decreases to its most stable frequency, usually between 12 and 15 breaths per minute. This steady, repetitive exchange of gases ensures that the carbon dioxide levels in your blood remain within a narrow 40 millimeters of mercury partial pressure range, maintaining the delicate pH balance of your internal oceans. Think about the way a forest floor recovers after a long day of sunlight. In the Pacific Northwest, the western sword fern, or Polystichum munitum, has fronds that can grow up to 6 feet long. At night, these ferns engage in a process called hydraulic redistribution. They use their deep root systems to pull water from the moist soil levels and release a small portion of it into the drier surface soil. This repetitive nightly redistribution allows the entire ecosystem to survive periods of drought. Your brain performs its own hydraulic redistribution tonight. It pulls the moisture of your experiences from the temporary storage of the hippocampus and redistributes it into the long-term soil of the neocortex. This process, known as systems consolidation, ensures that the most important memories of your day are watered and preserved. At this very moment, your muscle tone is reaching its lowest point, a state called atonia. This is controlled by the subcoaeruleus nucleus in the pons. This structure sends inhibitory signals down the spinal cord, using the neurotransmitters glycine and GABA to effectively switch off the motor neurons. This is a repetitive safety protocol that prevents you from acting out your dreams. It is a total surrender to the architecture of the bed, a physical manifestation of the trust your brain has in the repetition of the night. You are as still as the ancient stones of the Appalachian Mountains, which have been undergoing the same repetitive cycles of erosion and uplift for 480 million years. Notice the sensation of the air as it passes through your nostrils. It is a cycle that has occurred roughly 20,000 times since you woke up this morning. Each breath is a reminder that the most important things in life do not need to be new. They simply need to be sustained. The repetition of the breath is the ground note of your existence. In music, a ground bass or basso ostinato is a short theme that is constantly repeated in the lowest voice of a composition while the higher voices vary. Your life is a complex melody, but tonight we have returned to the ground bass, the simple, steady, repetitive heartbeat of being. As we conclude this exploration of the mind's love for the familiar, allow the educational details to fade into the background, leaving only the rhythm of the information. The predictive engine of your brain has found its answer. There is nothing left to solve. The loops are closed. The myelin is thick. The synapses are pruned. The glymphatic tide is rising. You are part of a planet that never forgets to spin, a heart that never forgets to beat, and a mind that never forgets how to find its way back to the silence. Let these affirmations settle into your consciousness, like the slow falling silt of a calm riverbed. My mind is a sanctuary of peaceful rhythms. The repetition of my breath is my anchor. I am in harmony with the cooling of the earth. My brain is skillfully organizing my thoughts while I rest. Every cell in my body is currently engaged in repair. I trust the steady cycle of the night. The familiar is my safety. The known is my home. I release the singular noises of the day for the steady music of the dark. My thoughts are as calm as the folded leaves of the silk tree. I am a masterpiece of biological consistency. The weight of my body is a signal of security. I am descending into the restorative valley of the delta waves. The work of the day is complete. The work of the rest has begun. I am part of the grand repetitive dance of the stars. Peace is my natural state. Rest is my birthright. The rhythm is enough. I am safe. I am still. I am at rest. Good night.